right here. So in the first example, we know a couple things. We know the delta y equals positive 2 meters, and we also know that the mass is 5 kilos, traveling a distance with a constant speed. Therefore, we can deduce the acceleration as well as the magnitude of the velocity is going to be both 0. Next, we will need to find the sum of all the forces, which is going to be mass times acceleration, but since acceleration is 0, the sum of all the forces are going to be 0. Overall, the work or the net work in total is going to be delta K. Delta K means the kinetic energy, but since the sum of all the forces are 0, then the net work or the total work is going to be 0 as well. In question B, it's asking what is the work done by the man. So first we gotta draw out what's happening. We have the mass in the middle, and we have the weight on top, and the work done by the man on the bottom. So the next thing we're gonna do is set up the equation. The work equals mg delta y, but in this case it's gonna be negative because the weight or the work done by the man is going towards the mass, so it's going towards the weight. In this case it's going up, that means it's negative, so we just plug in the values. 5 times 10 times 2, that's gonna give us negative 100 joules. So for question C, it's gonna be the opposite, because now the work is being done by the weight, therefore it's going towards the direction of the force being done by the man. So both are going in the same direction, that's why it's positive, but the result is the same. On the next example, we have the object moving from point A to point B, but throughout the journey or throughout the path, we're seeing that all the forces are going perpendicular to the displacement delta S. Therefore, we can conclude that there's no direction of displacement. For question B, we're being asked what is the work done by the force equals negative mg. So we know that the force is going to be mg times delta y, in this case y1 minus y2. In question 3, we have to use both things that we used in questions A and B. So we set up the equation. The net force equals the normal force adding up to the weight. So work on the normal force plus the work on the weight. We already know that the first one is 0 and the other one is mg, or we can also say that mg y1 minus y2 could be, or is actually, delta k in simple terms. Moreover, to expand this equation, delta k is the same thing as what's written here, and the net force can be written like this. So we go up, we solve the problem, and we set up two values. We set up the y2 equals 0, and we find the following. Next, we also set up the velocity initial being equal to 0. We set up both of these things equal to 0 because we're trying to find a value for the final velocity, which is pretty much what they're asking right here. What is the speed of point B? So at the end, it will be the final velocity. Therefore, we just plug in values, we cancel out the m, and we have square root of 2g y initial for the final velocity.